This lesson we're going to look at how to convert from denary to binary. We're still in data representation, we're still in numbers to give you some idea before we move on to characters, images, sound, etc. We'll probably have addition and maybe something like multiplication and division, really simple things though, nothing to worry about with multiplication and division left to do. And I may also do a sort of extension task on subtraction, but not to be done by all because subtraction just does not appear in the exam. So we're still in data representation. We're still in numbers, and we'll probably be in numbers for a couple of lessons yet. And these characters, images, sound, video, etc. may take just about one lesson each to cover. So, denary to binary, that's where we are. So, first of all, I'm going to pull up this table. I've given you this table again as a PDF. I think last time it was stored on my OneDrive, and so you may have had to ask permission to use it. This time I've attached it as a basic PDF, so you should be fine. What I'm going to try and do is convert 215 from decimal to binary. And if we look in the table, I've highlighted it in red here. Here's my 215, and it should give us this binary representation. So we've got something to check our answers against. And checking is going to be an important issue with this one. Again, I'm going to reiterate this. The exam board only deal with 8 bits, so the biggest number you're ever going to get is 255. It could be larger. The same method just continues on and on. But generally speaking, the exam board only deal with 8 bits, so the largest number you're going to get is 255. So let's look at how to convert 215 from denary to binary. First of all, we need this table again. This time we're only going to use 2 rows. I'm not going to bother with the powers of 2. I'm just going to set this table out to help me quickly answer the question. You may need it, you may not. I would suggest that you start using these tables until you're really familiar with things. So how do we fill it out? The top row, the dark blue row, we start off in the very right hand side, and I'm going to come to that at the end of the lesson. The very right hand side, we start off with 1, and then we double to get 2, we double to get 4, and we continue doubling until we finish off the top row. So we've got 1, 2, 4, 8, 16, 32, 64, 1, 2, 8. Please be careful with your doubling. If you end up with 1, 2, 5 here, it's completely wrong. This pattern, you'll use it so often it should stick in your head. But if you can't remember it, just start with 1 and keep doubling. So I'm writing down my number 215. And I need to convert this into 1s and 0s, which will go in the pale blue box. So how am I going to do that? Well, I do it with comparison. So here you can see I've highlighted 128. That's the first one I'm starting with. I am starting on the left hand side. Again, something I'll discuss at the end of this lesson. Starting on the left hand side, and I'm comparing the number that I've got, 215, with the value here. 215, well, it's bigger than that value there, so the number 215 must contain at least 128 and then some left over. So what we do is we say, okay, we've got 128, that lives in 125, we say it's true, and then we perform a calculation. We take away 128 from 215. Now this might be the tricky part of your conversion, not the actual binary or anything else like that, but actually the subtraction might be the difficult bit. So you need to have some check methods in at the end to know whether you've got it correct or not. So we're going to do this sum, 215 take away 128. So let's lay it out in the column way. 215 minus 28, let's go through it. 8 from 5 can't do, so we're going to borrow from 10, so that's 15. 8 from 15 is 7. 2 from 0, because remember we borrowed that 10, so we're going to cross that out, borrow 100 there. So 2 from 10 is 8, and then because we crossed that out and made that a 1, 1 from 1 is 0. So 215 take away 128 is 87. Any method you know, even if it's on a number line, will suffice. If you add these two together, the red and 128, you should get 215 as a way of checking. So we do the maths. So we've put 1 in because it contains, well, it's bigger than 128, so 128 is part of that with some left over, in fact with 87 left over. And we've got a new number, 87, that we're going to play with. So here we go, we start off with 87 and we move down a column. We don't start at 128 again, we move down a column. I've highlighted the 64 here and we compare our new number with 64. Well, 87 is larger than 64, which means that 64 is in 87 with some left over. And in fact, when we do the sum, we get 23 left over. And if you notice, if I add these two together, 64 and 23, I get 87. So I put a 1 in the 64, perform the subtraction to get 23, and then move on again. So now I'm on the 32 column. I've highlighted it there. 23 is larger than 32. No, that's false. 23 is not larger than 32. So it doesn't contain a 32. I've put a 0 in there. There's no 32s. 23 is smaller. I've just moved on. So I'm going to move on now, straight away, no maths, no subtraction, to the 16 column. 23 is larger than 16, so I'll write a 1 underneath the 16. It's true, and then I do the subtraction. 23 take away 16, and I'm left with 7. So that's my new number 7 to play with. I now check the next column along. 7 is greater than 8. Well, that's false. So I put a 0 underneath the 8 and move straight on, no subtraction. Check the same number against the next column. 7 is greater than 4. Well, that's true. 7 is bigger than 4. So I take it away. 7 take away 4 is 3. So what we're really saying here is that if I add 3 and 4 together, I get 7. So there's some left over. So 3 is my next number. I check the next column, which is 2. So I'm checking 3 against 2. Well, 3 is larger than 2. That's true. So I take it away. 3 take away 2 gives me 1. And really, I'm on the 1 column. I don't need to do any subtraction or anything. I've got 1 left over. So there is a 1 in here. That's it. So that is my conversion. 11010111 is my conversion from 215 in binary to 215 in denary to 11010111 in binary. And I could write my answer like this. 215 equals however, really that's not 100% correct, because that might be sort of a denary number too. I've got no idea. So I tend to put the subscript on. 215 in denary is equal to 11010111 in binary. So both of these are the same thing. This is just a little clearer and more accurate. So that's one way, and we can check our answer. And one way of checking our answer is going back to what we did in the table to begin with. So we look at what the pattern was in the table for 215. It was 11010111, and we can see that pattern here. Now notice how splitting it up into nibbles really makes it clearer to see than this. This is just that tiny bit harder to read than this value. They're the same value. Another way of sort of checking your answer is to go along. Perform the binary to denary, what you did in the last lesson. So I've got 128 plus a 64 plus a 16 plus a 4 plus a 2 plus a 1, and that should come to 215, but we'll have a look at that in a bit. So let's quickly have a go at another one. Slightly different way of presenting it, same method. So I want to convert the number 15 into binary. Draw my table, doubling the top row, starting with 1 at the right hand side, and then start from the left in my calculations. So 15 is definitely smaller than 128, so I just move on to the 64 column. 15 is smaller than 64, so I move on to my 32 column. 15 is smaller than 32, so I move on to my 16 column. 15 is smaller than 16, so I move on to my 8 column. Now 15 is bigger than 8, so I write a 1 underneath my 8. And take these 2 away. 15, that's the number I had. Take away the 8 that I've just used, and I'm left with 7. That's my next number to play with. And I'm moving along to the column. And I think you can already see the numbers making up 7 here. So let's try it now. 7 is bigger than 4. So I write a 1 underneath the 4 and I take 4 away from 7 to give me 3. That's my next sum. So 3 is bigger than 2. So I take 3 from 2, write a 1 in my 2, and I'm left with 1. So I just write a 1 there. So my answer here would be 0, 0, 0, 0, 1, 1, 1, 1. Now you can do either way. You can write out this in words, or you can show me the arithmetic. But either way, it's showing me a method, and definitely putting the table up here as well is showing a method. Don't just be tempted to write down the answer as if you'd used a calculator. You need to write down whatever method you're using. So practice these. So there we go. That's our number 0, 0, 0, 0. Notice that if it's smaller, there's a 0. If it's bigger, there's a 1 until we're left with the last one. It's either a 1 or 0 to put in there. Another thought. Okay, let's try this. 5. Let's make the number really, really simple. I want to convert 5 denary to binary. And we've just got to think of what numbers make up 5 using these. And you know that. The only numbers that make up 5 along here are 4 and 1. Add those two together, you get 5. So the binary is 1, 0, 1. Everything else is going to be a 0. And that's true of every number. You're not going to have a different way of writing 5 on here. There is only one way of writing a number in binary. So you can work it out using all of these without sort of writing down any methods. Like I said, be careful. Write down your methods. Okay, the final bit, terminology. I said start at this end and write down your doubling from this end and start at this end. There are some terms for this particular bit here, the first one on the right hand side. That is called the LSB, or least significant bit. It means it's the smallest value digit. So a 1 in here means it's 1, as in 1p, not a pound. On the other end, I've got what we call the most significant bit, MSB. That's the largest value we can have, which is, in this case, 128. Moving along, it would be 256, then 512, and so forth. But if we've got 8 bits, which is definite for the exam board, the most significant bit is the left-hand bit, and that is bit 7. Because we number the bits 0, 1, 2, 3, 4, 5, 6, 7. Okay, and the least significant bit is bit 0. The value of bit 0 is 1. The value of bit 1 is 2. The value of bit 2 is 4, and so on. So that's some terminology for you, which I will be using in future. Most significant bit, least significant bit. Understand which end of this binary number it stands for.